Alright, today's lesson's over sex-linked traits. You should have out your notes. I'm not going to go over your previous homework with you since I did it on the previous video from last class. Alright, first of all, I want you to look over here to the corner and look at the orange dot. If you can see the number that's in the dot, then you are not colorblind. If you have an issue seeing what's in the dot, then you should probably go see a doctor. Because you should see the number 74. It's right here. Okay. If you cannot see that, then you should probably go get your eyes checked. But colorblindness is a trait that's passed on from your parents to you in a unique way that we haven't really talked about yet. But colorblind individuals can see some colors, just not all colors. It depends on the type of color and the type of color blindness. Okay, first of all, there are carriers of sex-linked traits, which means that somebody can carry the trait but not actually have it. And so a carrier right here is what you're going to have to write down. Your definition is a heterozygote, which means they have one big, one little, right? Okay, they carry a recessive gene, but they do not express the gene, which means it's not turned on, which means you can't see it in their phenotype, okay, or the way that they look. So, if you look over here in your little chart, you have a unaffected carrier mother, which means that she carries it, but she does not have it. Okay. Alright, here's a pedigree. And last class you learned that males are squares and females are circles, so boys are boxes. Remember that I told you that boys are boxes. And you will always have a key when you have a pedigree. Okay. The pedigree shows how colorblindness is passed down in a family. What patterns do you notice? So first thing I want you to notice is that some are half shaded in and some are fully shaded in. Okay? If you look at the half shaded in ones, that means that it's a carrier. Are there any boxes that are carriers? No. Because the only sex-linked trait that you're going to learn about is the one carried on the X's. And we're going to talk more about this in a second. Females are more likely to be carriers, while males tend to actually get the disorder. So the only ones that are colored in here are the males. No females actually have it in this scenario. Okay, again, colorblindness pedigree is the same thing that I just had pulled up. Whether or not you get a trait like colorblindness is linked to your sex, which means male or female. Males are colorblind far more often than females, and because of that, we call it a sex-linked trait. Humans have 23 different pairs of chromosomes. You've learned that already. This is called the karyotype, okay, or genome, sorry. And 22, the ones that are highlighted in yellow, are called autosomes. Okay, kind of like the car place, to remember that. 22 out of the 23 are autosomes. And the genes on the chromosomes are passed down equally between the male and the female offspring, which means that each one has two types, or two sets. And we already know that. You get one from your mom, one from your dad. Alright, the reason that some traits are linked to the sex of the offspring is because they're carried on these sex chromosomes, which are your 23rd pair. And you should already know that males are XY and females are XX, and you can see this in your chart. And that is a typo right here, so ignore that. So that's supposed to be XX. Alright, since males only get one copy of every gene that's carried on the X chromosome, because they only have one X, so they only get one copy of each gene. They don't have anything to cancel it out. Okay, so continuing on, sorry, I had to pause it for a second. You have, if you are a female, you have two X's, okay? If you are a male, you have an X and a Y. So, since males only have one X, they only get one copy of everything that's carried on that X. Okay, so because, again, males only have one X, they express all of the genes that are on the X, whether they're dominant or recessive. So everything on their X will be in their phenotype. It will show up, it will be expressed, it will be turned on. Okay? So if a male gets a mutated X or a mutated gene on his X, that chromosome will mean that he has the disease, and so the male will have the disease. Okay? I know it's a little bit confusing, but if you look at your pedigree, you can see that the males either have it or they don't. And there's no carriers. So if the male has a mutated X or a changed X, it's going to mean that he has the disease. Okay, females can be carriers. They do not have to have the disease because they have 2 X chromosomes. So they kind of get to counteract and choose which one's the best. Okay, so that's why a lot of females are not colorblind, is because they actually get to kind of counteract the other X. So if you have a mutated X and a regular X, the regular X will take over. Okay, and it keeps them from actually getting the disease. So, does it mean that females never get a sex-linked trait? No, it does not. Females can have a sex-linked recessive trait like colorblindness, but it's very rare. It requires a father with the trait, so the father is colorblind, and the mom has to be at least a carrier. Okay, so if the mom has a mutated X and she passes on that mutated X, then the daughter also gets the X from the dad, who's also mutated. Okay, and you can see that in this pedigree up here. Okay, mutated X is over here, and I'm just going to put a little dot on it. Regular X, and then the dad has a mutated X with a Y and passes on that to the daughter and that one to the daughter. Okay, if a woman is a carrier, there is a 50% chance that her sons will get the trait. Whether or not males get sex-linked trait depends on the genotype of the mother. Mothers always give their children an X chromosome because they have 2 X's, so they have to give away an X. Okay? Sons always get the Y from their dad, and the Y does not determine the sex-linked trait. So if the mom's a carrier and she has 1 mutated X and she passes that one on to her sons, her son will be colorblind. Okay? If she passes on her regular X to her son, then her son will not be colorblind. Okay, if a woman has a sex-linked trait, there's a 100% chance that her sons will have the trait. So if the mom is colorblind, all of her sons will be colorblind. Whether or not a male gets that sex-linked trait depends on the mom completely. Okay, mothers always give their children an X chromosome. Okay, since the guys only have 1 X, they can't counteract whether or not that X shows up. Okay. Sex-linked traits never pass from father to son. Okay, the reason why is because the father gives the son the Y. Okay, that does not determine what is on that sex-linked trait. So, father's XY only passes on that Y to their sons every single time. Okay, that's why it's a boy. Okay, if a man has a trait, his daughters will at least be carriers. So, if a dad is colorblind, okay, he has to pass on that mutated X because that's the only thing he can pass on to his daughters because daughters have 2 X's. So he always passes on that mutated X to his daughter, which means that they will at least be carriers. And that's obviously what makes them females. They have 2 X's. Okay, on your sheet you should see something similar to this. It says a normal male and a female carrier of colorblindness have children. Write a statement summarizing the offspring that they will create. So how you want to do this is you'll actually carry the CB over. So you have 1 X from up here that's regular, then you're going to have an X that's a CB, which means colorblind. Okay, so this right here, if you have a regular X and a colorblind X, that is a female carrier. And then over here, you have a regular X. You know how to cross these already. So I shouldn't have to do a whole lot of explaining other than the colorblind. Okay, X, X, and I'm just going to put a dot because it's easier. X, X, okay, that's a regular X colorblind with a Y and an X, Y. Okay, so write a statement summarizing the offspring. I want you to look in each box. So this box right here, circled in red, you have a female who is colorblind, correct? Out of how many females the colorblind? So you have 2 females, right? And 1 is colorblind, so you have half. Okay. And then over here on your males, and she's colorblind carriers, I should say, because she doesn't actually have it. In order for a female to have it, she has to have 2 XCBs, which is up here in the corner that I'm circling. Okay? So, going on to the males, you have half that are actually colorblind. So, half males are colorblind. Okay? Next one that you have, you're crossing a colorblind male with a normal female, and they will have children. So write a statement summarizing the offspring. So you have an X, and then an X colorblind, an X, and then an X colorblind, XY, XY. So your statement should say something along the lines of, or all the females will be carriers, and none of the males will be affected. Okay, I want you to go ahead and do your practice. If you need extra help, go back and watch the video again. I talked really fast in this video, so if you need Miss Shirley to replay it and then pause it, just please ask, okay? And I can remove this right here so you can actually see it. There you go. So that's your explanation right there. All right, good luck, guys.